So have you ever opened up your AI API bill, taken one look at the numbers, and just thought, what is going on here? You see one price for the words you send in, and then a much, much higher price for the words the AI sends back? Well, if that's you, trust me, you are not alone. In this explainer, we're going to get to the bottom of exactly why that happens. This is really the central mystery, isn't it? Why does it cost so much more for an AI to talk than it does for it to listen? It feels kind of backwards, but the answer, well, it's hidden deep inside the model's architecture. And this 3 times number, that's often just the start. With some models, you're looking at 4, 5, maybe even 10 times more expensive. And that is a huge difference with some major implications for anyone who's actually building with this tech. Okay, so there's actually a name for this whole thing. The asymmetric bill. You can think of it as a fundamental economic rule of working with LLMs. And it's simple. Reading, your input, is cheap. But writing, the AI's output, is expensive. And once you really get it, you can start to master it. So let's break down both sides of this equation. First up, let's look at the easy part, the cheap part of your bill, the input. I want you to think of the AI's hardware, the GPU, as like a professional speed reader. It doesn't read your prompt word by word like we do. No way. It uses something called parallel processing to look at every single token of your input at the exact same time, all in one massive gulp. This whole phase is called the prefill. And because it's happening all at once, it's incredibly fast and super efficient. That efficiency is exactly why input tokens are the budget-friendly part of your bill. So, we know the input side is a fast, parallel gulp, and that's what makes it cheap. But what in the world is happening on the output side that makes it so expensive? This is where the whole story changes. All right, now for the main culprit behind that high price tag, the output. You see, if input is a gulp, then output is more like a slow, careful stitch. The key term to understand here is autoregressive. Now, I know it sounds really complicated, but it just means the model generates its response one piece at a time. It predicts the next word by looking at your entire prompt, plus every single word it has already written. And this right here illustrates the process perfectly. To generate just the first word, it reads your prompt. Then, to generate the second word, it has to reread your prompt and that first word. To generate the 100th word, it rereads your prompt plus the 99 words it just wrote. It's this repetitive, one-by-one loop. And this is the heart of the issue. Each new token requires a brand new, full-blown, expensive calculation. This whole phase is called the decode phase. And because it's sequential, not parallel, it keeps that expensive GPU rented for a much, much longer time. That's where your 3x price hike comes from. But wait, there's more. You see, there's another hidden cost lurking in this whole process, something you can think of as the memory tax. This is the logical next question, right? You're probably thinking if generating the 1,000th word means reprocessing the prompt and the previous 999 words, shouldn't it just get impossibly slow and way more expensive with every token? And you'd be right, it would, except for a really clever trick called the KV cache. Just think of it as the model's short-term memory. It stores the complex math from all the previous tokens, so it doesn't have to recalculate everything from scratch every single time. It is a huge performance booster. But here's the catch. This is where the hidden cost is revealed. That KV cache, that short-term memory, has to live in a very special, very fast, and yep, very expensive place called VRAM. And as the quote says, it's pretty much the most expensive digital real estate on the planet. So the crucial point is this. When you ask for a long output, you aren't just paying for the thinking time. You are literally paying rent on that high-speed VRAM to hold the cache. So the longer the output, the bigger the cache, and the higher your rent. So, okay, now that we've cracked the mystery, how do we actually use this knowledge to our advantage and build more efficiently? Okay, here are 3 really actionable strategies. First, be concise. Seriously, force the AI to give you shorter answers because every single output word has that heavy tax on it. Second, front-load your context. It is way cheaper to give the model a 10-page document to read as input than it is to ask it to write a 10-page document as output. And finally, use tools like token calculators to see these cost ratios in the real world before you build. The takeaway here is pretty simple. Once you understand the economics of this generation loop, you can stop paying the wordy tax. You can design your prompts and your applications in a much smarter, much more cost-effective way. So I'll leave you with this question to think about. Knowing that every word of output is a slow, expensive stitch, and every word of input is a fast, cheap gulp, what are you going to architect differently? What will you go out and build more efficiently?